Hey everyone, welcome back to another quantitative reasoning video. And we're going to talk about Unit 8A today, growth of a function or growth of a model, linear models versus exponential models. Those are two very common basic models that we use in mathematics, and so we should talk about how they are related and how they are different. So linear growth occurs when your quantity is growing by the same absolute amount each unit time. So what do we mean by absolute amount? That means we are adding or subtracting the same amount every single time. So it goes up by 4 every time. It adds 4 each time. It subtracts 3 each time. That's a linear type of growth. Exponential growth occurs when a quantity is going up by the same relative amount, and that is either multiplication, okay, or division, and can sometimes be expressed as a percentage, right? Because percentages are relative. 10% of 100 is different than 10% of 1,000. So multiplicative growth is what exponential growth is, okay? So if you double something, that you double the size, bacteria doubles every 20 minutes, that's exponential growth, okay? And what happens with linear growth is just a straight line. It's a line, linear, all right? Where exponential growth, when you're being raised to a power, that grows much, much faster, okay? And it doubles over a certain amount of time, all right? So the basic forms of our equations for linear versus exponential. Linear, right? X and Y are the variables. And so B is what we call the initial amount, and that is when x equals 0. Okay, so it's not necessarily the first, if you're given a table of values, it's not necessarily the first number in your table, it is when x equals 0. Okay, over here, A is the initial amount, and it's not really convenient that we use different letters, but it's just the way that it works, and so that's when x equals 0 also. And then here, M is the amount of the absolute change. So if it's positive, then that's an increase, and if it's negative, that's a decrease. So if it goes up by 4 every single time, if we're adding 4 every time, then M is 4. If we're subtracting 3 every time, then negative 3 is M. All right. Here, B is the multiple. So if we're doubling, that would be B is equal to 2. If we're dividing things by 3, multiplying by a third, then B would be a third, okay? B always has to be positive though, okay? B's never negative here. We can decrease by multiplying by a number smaller than 1, but we never multiply by a negative number, okay? We don't change signs. So, example here, linear growth. As x is going up by 3 every single time, negative 3 to 0, 0 to 3, 3 to 6, 6 to 9, what does it look like y is going up by? It looks like y is increasing by 4. We're told it's linear. So that means we just add 4 again. So the next number is 9, and then we add 4, we get 13, 17, and 21. Okay? If you want to know how much you're going up by y is going up by 4 every time x goes up by 3. And so M is the slope of this linear equation, y equals 4/3, 0 when x equals 0, y equals 5, and so that's B, and so you get y equals 4/3 x plus 5 if you need to write the equation, okay? For exponential growth, we're told exponential growth will never go up by more than 1 at a time because we're not equipped to really handle that, and so here we're multiplying by 3. Here we multiply by 3 again, right? 1 times 3 is 3. 3 times 3 is 27. 27 times 3 is 81. Times 3 is 243, right? And so on. Multiply by 3 again, you get 729. So exponential growth here, A is equal to 27 because that's when x equals 0, and we're multiplying by 3 every time, and so the equation is 27 times 3 to the x power. I like to put the base in parentheses just so there's no doubt as to what's happening there. Remember that exponentials happen before multiplication, so this 3 to the x power, this 27 and 3 can't get multiplied, right? This is separated. 3 to the x power is alone. The 27's out front, but you have to do this stuff first because exponentials come before multiplication, okay? So let's do a couple more examples, and then I'm going to have you do a couple. I want you to decide whether or not the example is linear or exponential, and then answer the question, okay? So the number of students at Wilson High School has increased by 50 each year. If the student population was 754 years ago, what is it today? Well, if it's up by 50 every single time, that's a absolute change of 50 each time, so that's linear, okay? And we'll come up with the equation. How much did you start with? You started with 750, and then we're going up by 50 every year. And so y is equal to 50x plus 750. And so if we want to find how much it was today, then we plug in 4 there. We'll show that here on the next slide. The price of milk has been rising 3% per year. If the price was $4 a year ago, what is it now? Well, $4 is our starting point, so that's A is equal to $4. 3% is what we're going up by. However, remember that 100% is exactly how much you have. So if you multiply $4 times 100%, you have $4. So we have to take that 100% and that 3%, and that gives us 103% increase. In other words, we multiply by 1.03. B is 1.03. And so we get y equals 4 times 1.03 to the x power. Okay. So 4 times 50 gave us 200 students. When we add that to 750, we get 950 students. Y equals 50 times 4 plus 750. Okay, you can reason it out or you can use the equation. I'm fine with either one. All right, exponential growth. 3% of $4 is 12 cents. So the price was $4.12, or the way we would have done it using our formula, we have 1.03 to the 1 power, and that would give you $4.12 when you multiply that out on your calculator. Okay, you can do it either way. You can reason it out, or you can use the equation. All right. So here's what I'd like you to do. I'd like you to determine all 3 of these. I'd like you to determine whether it is a linear or an exponential. Just write L or E next to it. Okay, back here I wrote L for the first one and E on the second one, exponential. All right, so you do that now. Here, write L or E, and then, if you can, see if you can figure out what the equation is supposed to be and answer the question. Okay, so pause the video, take a few minutes to do this. It'll take you a couple minutes. So pause the video, come back, and we'll go over it together. Okay, so tax law allows you to depreciate the value of your equipment by $200 per year. You purchased the equipment 3 years ago for $1,000. What's the value today? $200 per year. That's a fixed amount, so that's linear, but you're subtracting, right? So B is your starting value. That's 1,000, but you're supposed to be subtracting value from it, so the M is negative 200. Okay, so you get Y equals minus 200x plus 1,000, and then that was what? That was 3 years ago. And so if you plug in 3 for x, right, and again, you could do that in your head. 3 times 6, 3 times 2 is 6, and so you'd get, negative 600 here. You'd go down by 600, and so it's worth $400 now. Obviously, this model only works until you get down to 0, and then it doesn't make any sense anymore. But so that was a linear one. Okay. The memory capacity of state-of-the-art computer storage doubles every 2 years approximately. Doubles, that's talking about exponential. And when you hear doubling, that tells you the B right away. B is 2. That's easy. All right. So if a company's top-of-the-line drive holds 16 terabytes today, what will it hold in 6 years? So A is the starting point, 16. And so again, our formula for exponential is that. So you get 16 times 2 to the 6th power. All right, and I need my calculator for this one. 16 times 2 raised to the 6th power, 1,024. So the answer is 1,024 terabytes. Make sure your units were appropriate. If it's money, then put $sign. If it's units, put units. Okay. Part E, the price of a high-definition TV has been falling about 25% per year. As soon as you see percentage, you know that's exponential. But be careful of how you get the B, okay? A is the starting price, that's $1,000, that's easy. But B, remember, if it's a percentage, it's based off of 100%, and then we add or subtract. We're falling, it's exponential decay, not growth. And so we subtract 25% from 100 to get that our new value is going to be 75% of the old value, and 75% is, as a decimal, 0.75. And so we get y equals 1,000 times 0.75 to the x. We want to know what the price will be in 2 years, so we're going to plug in 2. And so once again, we need to pull up our calculator and do 1,000 times 0.75 raised to the 2 power. We get $562.50. Okay. So pretty straightforward. There's a number of problems for you to practice on the worksheets from 8A. Just remember, exponential growth leads to repeated doubling. With each doubling, the amount of increase is approximately equal to the sum of all the previous doublings. So that's kind of a cool little relationship. And exponential growth can't continue forever, all right? That doesn't make any sense. There's usually some sort of limiting capacity. But again, that's really outside of the scope of this course, just to understand that you can't double forever, right? You can't get bigger forever. Eventually, you're going to run out of space, you're going to run out of time, you're going to run out of whatever. So there you go. All right, but those are a couple key facts about exponential growth. Take a look at 8A, take a look at my math lab, and let me know if you have any questions. Thanks. See ya.